रुक कहे गया, आओ आगे।
हमको बुर्बक समझे हैं का? हमार मालिक बोला है कि एकरा से आगे मत जाना, नहीं तो फुका जाएगा।
होशियारी करता है हमरा से। कौन है जी तुम्हारा मालिक?
इसरो इसरो
इसरो? ये कहाँ पर है?
पृथ्वी पर है।
पृथ्वी पर कहाँ?
वहीं जहाँ रोज सुबह सुबह आपको नमस्कार किया जाता है और ठंडी में तो बहुत याद किया जाता है।
गर्मी में?
गर्मी में तो सब तबाह रहता है आपसे। दोपहरिया में कोई नहीं देखना चाहता है आपको।
ओ, भारत से आए हो?
हाँ, वहीं से। रुकिए, फोटो खींचेंगे आपका। मालिक को भेजना है, अब पड़ोसी को भी तो जलाना है, नहीं तो मालिक बोलेगा कि 400 करोड़ रुपया बर्बाद कर दिया।
अरे तुम 400 करोड़ में यहाँ तक आ गया? हाई 3-4 ठो और आया हुआ है। ये फेंकुआ सब तो 3-4 हजार करोड़ के नीचे का बातें नहीं करता है सब। तुम इतना सस्ता में कैसे आ गया?
अरे तो हम लोग भारतीय ना हैं, टैलेंट की कमी थोड़ी है। अब हमको फोटो खींचने दीजिए।
अच्छा रुको, पोज देने दो।
Hi friends, so ISRO has again made us proud after the successful landing of the Chandrayaan-3 on the South Pole. Now Aditya has been placed in the L1 Lagrange region from where it can effectively study the activities happening on the sun. So today I will be talking about the chronological events of how this whole activity took place and who is this project director who has effectively pushed her team to make this complete project of the Aditya L1 successful. And finally, I will be talking about why do we need to study the happenings and the activities happening at sun. So before I go ahead, I'll request you to see the complete video, and also you must have seen my previous video on Aditya L1 when it was launched. This momentous occasion has been told to be a landmark event when Prime Minister Modi congratulated the ISRO team, and our president has said that this is one more step towards women empowerment or Nari Shakti, as she congratulated the complete team for their successful placement of the spacecraft. So the chronological events of how the whole activity took place is that on the 2nd of September, ISRO launched the Aditya N1 on board the PSLV C-57, and on 3rd of September, the first earthbound maneuver was performed successfully, attaining an orbit of about 245 kilometers into 22,459 kilometers. On the 5th of September, the second earthbound maneuver was performed successfully. The new orbit attained was 282 kilometers into 40,225 kilometers. On 10th September, the third earthbound maneuver was attained by putting the spacecraft into an orbit of about 296 kilometers into 71,767 kilometers. On the 15th of September, the fourth earthbound maneuver to achieve a new orbit of 256 kilometers into 121,973 kilometers was performed very successfully. On 18th September, the Aditya L1 commenced the collection of scientific data, and on 30th of September, the spacecraft escaped the sphere of the Earth's influence and went into the Sun-Earth Lagrange point of L1. On 6th October, trajectory correction maneuvers, that is the TCM, was performed for about 16 seconds to correct the trajectory. The TCM ensured that the spacecraft was on its intended path towards the halo orbit insertion around L1. Then on the November 7th, the HEL-1OS payload captured first high-energy X-ray glimpse of the solar flares, which I have explained in my previous video. On 1st December, the solar wind ion spectrometer, that is the SWIS, in the Aditya solar wind particle experiment, that is the ASPEC payload, was made operational. On 10th December, the SUIT payload captures the full disk images of the sun in near ultraviolet wavelengths. And finally, on 6th of January, it was a proud moment when the Aditya spacecraft was placed successfully in the L1 region, which is a region where it is out of the gravitational force of the earth, and also the centrifugal force acts in such a way that the spacecraft is stationary relation to the earth and sun and stays at that same point, and from where it can effectively study the complete happenings or the activities of the sun itself. Now, the ever smiling project director of this project, who led the complete project to its success, from where the Aditya will do Surya Namaskar every day towards the sun, is Nigar Shaji, who is a very gentle, ever smiling lady and an representing factor of today's women empowerment. Shaji joined the elite space agency in 1987 and rose through the ranks to become the project director of India's first solar mission. This 59-year-old lady, who was earlier the associate product director of Resource Sat 2 Alpha, which is still operational, is also the project director for many lower orbit and planetary missions. She started her stint in Isro by working at the Sriharikota Space Center of the Andhra coast and was later shifted to the U.R. Rao Satellite Center in Bangalore, which is the key center for developing satellites. She was born in a Muslim Tamil family in Sengotai in Tamil Nadu's Tenkasi district, and she did her schooling in Sengotai before getting admitted to the Government College of Engineering, Tirunelveli, under the Madurai Kamaraj University, where she earned her engineering degree in electronics and communication. Later, she did her master's in electronics from BITS Mesra, and Shaji's father, Sheikh Miran, a mathematics graduate who turned to farming by choice, was always the big inspiration of her life. She says that both my parents were supportive throughout my childhood, and because of their continued support, I could rise to such heights and could undertake such projects. Now, why do we need to study the sun? Why so much of efforts for that? So now that the Aditya L1 is an observatory at this point, we must know that the reasons for studying the sun are basically that sun produces a lot of energy through nuclear fission in its interior and emits it from its outer layer. The photosphere at 6000 degrees Celsius layer emits all visible and infrared light, which is crucial for life. Above this is the chromosphere, and higher still is the million degrees Celsius hot corona. Interestingly, the corona is much hotter than the inner layers of the sun. That is, the outermost layer is the hottest, and this is a major energy source which provides the heat. However, there are processes which take place which are still not fully understood. Though sun gives us light, but the ultraviolet rays and the X-ray radiations which are emitted from it are very harmful for living beings and also for us humans, which can be very lethal in turn. The sun also continuously streams electrically charged particles, a stream known as the solar wind. Again, this has been explained in my previous video. These charged particles produce the spectacular array known as the northern and the southern lights, seen close to the north and the south poles of the earth. Then there are certain bursts of charged particles which come into the interplanetary space and are known as solar flares. And this coronal mass ejections are heat thrusts which come out from the sun and emit lot of energy which affect the space weather, and space reliant technologies get affected, and then there are blackouts in the earth's various latitudes which are there, that is the higher latitudes, and these are very difficult to predict. So we need to carry out tests and studies of these activities of solar flares and the energies that are emitted from the sun, so that we can get to know the pattern of these energies and amend our lives or take care to safeguard ourselves from them. Since the Aditya L1 is located outside the Earth's atmosphere, its instruments can observe the ultraviolet radiation from the corona and in the process better understand its workings. Moreover, we need to monitor the solar atmosphere and the corona continuously to monitor the eruptions on the sun and study the properties of these charged particles in the solar wind. Critically, this can only be done when you are outside the Earth's atmosphere and also the gravitational force. So right now at the L1 Lagrange is a point which is on the sun and earth axis, which is free from the gravitational force, the centrifugal force, and is a point which is relatively constant as the earth revolves around the sun. So the Aditya spacecraft can continuously view the sun and its activities with its instruments focused towards it. Aditya L1 has 7 instruments for the observation of all radiation and charged particles. Its location is 1.5 million kilometers away from the earth towards the sun, which allows us uninterrupted observations. So L1 stands for the first Lagrangian point, and there are 5 such points L1 to L5 associated with the motion of one astronomical body around the other. In this case, it is the Earth and the Sun. So now we have the Earth at such a position where we can constantly monitor the activities of the Sun. And let us see how these experiments and these data collation will assist us in future work, as these will be translated into cognizable intelligent datas. So please keep following us and share this video amongst your friends so that these topics of interest can also be a point of knowledge for other viewers. And also write in the comment box below if you would like me to talk on other topics also. Happy viewing. Jai Hind.